Okay, welcome back to another video on the Math channel. It's your teacher Mr. Lim here, and in this video we are going to be looking at arc length and sector areas in radians. So by the end of this lesson you'll be able to derive the formula for arc length and for the area of a sector of a circle in radians, and solve problems involving sector areas and arc lengths. So let's have a look at the first thing, deriving the formula for arc length in radians. So I thought it would be a good idea for us to just review how to find the length of an arc when we're given an angle in degrees. So let's say, for example, we have this angle here. If we want to find out the arc length, which is this bit, I'll just call it L, then normally we would say that the arc length has to be the angle out of 360, because it's a fraction of the circumference of a circle. And the circumference of a circle is 2 pi r. However, if we are to do the same thing but to do it in radians instead of degrees, then the arc length is going to be the angle in radians divided by 2 pi. Why 2 pi? Because 2 pi radians is equal to 360 degrees. Okay, we've mentioned that in a previous video. So instead of dividing by 360, we're dividing by 2 pi. So we've got theta divided by 2 pi, and we're going to multiply that by the circumference of a circle, because it's a fraction of a circumference of a circle, 2 pi r. And what you'll notice here is, if we were to write this as a fraction over 1, 2 cancel each other out, pi cancel each other out, and we're left with theta times r. So the formula that we will use, I like to write it as L is equal to r theta, because that just rolls off the tongue better. So if we want to find the arc length of a circle or of a sector, we use L is equal to r times theta in radians. Okay, so if you're given a question in degrees, you need to convert it into radians. Alright, let's derive the formula for the sector, for the area of a sector of a circle in radians. So let's say we've got something like this now. Okay, if we want to find the area of this sector, normally we say that the area of the sector is a fraction, the angle out of 360, because it's a fraction of a full circle. And what's the formula for the area of a circle? It's pi r squared. But just like the formula for the arc length, if we were to do this in radians, instead of dividing by 360, we divide by 2 pi, because 2 pi radians is equal to 360 degrees. If we multiply that by pi r squared, we can notice that the pi's will cancel each other out because it's over 1. And we're left with a is equal to theta on 2 times r squared. Now I like to write this as r squared theta on 2. So length is r theta, arc length is r theta, area is r squared theta on 2. Okay, so now we know how to derive the formula for arc length and area of a sector. Let's solve some problems involving these two things. Question A. What is the length of an arc subtending a right angle at the center of a circle of radius 150 centimeters? So what I'm going to do is I'm going to draw a circle. It's going to have a radius of 150 centimeters, and it forms a right angle according to the question. Okay, a right angle. Okay, so the question is asking us for the length of an arc. That means we need to know what that is equal to. We know that length is equal to r theta, radius is 150 centimeters, and theta is the angle in radians. So here we've got 90 degrees, but we want to convert that to radians. We just divide it by 180 and put a pi in the numerator. 90 divided by 180 is half. So we just have 1 pi, or we can have pi on 2. So if the question asks you for an exact answer, what you could do is just do 150 divided by 2, which is 75. So it's equal to 75 pi centimeters. Okay, so all we did was we did 150 times 2, and we left the pi in our answer. However, if the question asks you to give your answer correct to 1 decimal place, for example, we can just put that in our calculator. We can do 150 times pi on 2. Oops. Which is 235.6. And that's to 1 dp. Okay. Question B. Here we're sort of working backwards. What is the radius of a circle in which an arc length of 4 meters subtends an angle of 120 degrees at the center, round to the nearest centimeter? So here we're going to draw another circle. Okay, so 120 degrees. That's about 120 degrees. We know that the arc length is 4. And we need to work out what the radius is. So we know the arc length is equal to r theta, or 4 is equal to the radius times theta, except we've got 120 degrees. So to convert that into radians, we just do 120 divided by 180, which is 2/3, and we put pi in the numerator. So it's 2 pi on 3 radians. So I'm just going to do r times 2 pi on 3. So if I want to get r by itself, I multiply 4 by 3 and then divide it by 2 pi, which becomes 12 on 2 pi is equal to r. So the radius is equal to 6 on pi meters. Now that's exact. Because the question asks here to round our answer to the nearest centimeter, we can just put in our calculator 6 over pi. By the way, make sure that your calculator is in degrees. 1.91 meters. Okay, and that's to the nearest centimeter because there are 100 centimeters in a meter. So 2 dp. Alright, question C. What is the exact area and the perimeter of a sector subtending an angle of 45 degrees at the center of a circle with a radius of 8 meters? So again, I'm going to draw a circle. Yep. Let's do that again. Okay, so we need an angle of 45 degrees. That's about 45 degrees. We know that it has a radius of 8 meters, and we want the area as well as the perimeter. Perimeter I'll just highlight in green. Okay, so let's do area first. We know area is equal to r squared theta on 2, which is 8 squared times, well, we need theta in radians. So all I'm going to do, 45 degrees, I'm just going to divide it by 180. Put it as a fraction, 1 over 4, so it's equal to pi on 4. Okay, and remember we just put pi in the numerator. Pi on 4, and then we're going to divide that by 2. So the question says exact, so I'm not going to put pi in. in my calculator, I've got 8 squared divided by 4, and then I'm going to divide my answer by 2, which is 8. So 8 pi square meters. Okay, so in my calculator, I just did 8 squared times 1/4, okay, because that's 1 pi over 4, and then I divided it by 2. But I still have this pi I need to put in my answer to keep it exact. So it's 8 pi square meters. And to find a perimeter, the perimeter is just the arc length, which we know is r theta, plus the 2 8s. 8 plus 8 is 16. So we have r, which is 8, theta is pi on 4, and then we're going to add 16. 8 divided by 4 is 2, so technically we have 2 pi plus 16 meters. Okay, 2 pi plus 16 meters, that's the perimeter. Okay, question D. A circular cake has radius 3 centimeters. What is the angle subtended at the center by a sector of area 20 square centimeters? Write an exact answer in radians and a rounded answer to the nearest degree. Okay, so let's draw a circle. Okay, we know it has a radius of 3. And the area of the sector is 20 square centimeters. Now, I don't know where I need to draw this other radius, but what I do know is that the area of a circle is pi r squared. So if I do pi times 3 squared, what do I get? 28 square meters. Oh, sorry, square centimeters. Because 20 is more than half of that, I am going to assume it's going to look, actually let's do this. Let's do 20 divided by that. Okay, so it's close to 3/4, but it's not, so I'm just going to guess it's about there. And so I want to know how big this angle is. Okay, I know that the area of this sector is 20 square centimeters. Okay, so the area of this sector here is 20 square centimeters. And I want to work out what that angle is. So area is equal to r squared theta on 2. I know that the area is 20, radius is 3 on 2. So that means we have 40 over 9, because I'm just going to multiply that 20 by 2, and then divide it by 3 squared, which is 9. So we have 40 over 9 is equal to theta. Okay, and that's the answer in radians. Okay, if I want to convert radians into degrees, I know that pi radians is equal to 180 degrees. And so here I've got 40 on 9 radians. So if you remember the trick that I taught you in a previous video, if we want to convert that into degrees, we take this bottom number, divide it by what's above it, and then times that answer by what's across it. So we'll take our 40 on 9, we're going to divide it by pi, and then we're going to times it by 180, which is 254.6 degrees. So to the nearest degree, 255 degrees. Okay, so here's exact in radians. Here is rounded to the nearest degree. Okay, question E. Find the area and the perimeter of the major sector DAC in the diagram below. Round your answers to 2 decimal places. Okay, so it's very important that we know that we are looking for the major sector. So the major sector is this entire area. Okay, all of this. This is the major sector. So we want to find the area and the perimeter. So area is equal to r squared theta on 2. Radius is 25. This angle, however, we need to work out. And it needs to be in radians. So we know that in degrees, it's 360 minus 30, so 330 degrees. So if I want to convert that into radians, I'll just divide it by 180. And then put pi in the numerator. So it's 11 pi on 6 radians. So we've got 11 pi on 6. And then we're just going to divide that all by 2. So the question here says round your answers to 2dp. So I'm just going to put all of that into the calculator. 25 squared times 11 pi on 6 all over 2. 1799.87. And because this is area, it's square meters. If I want to work out perimeter, I need all of this, which is called the arc length, and then I need to add these 2 sides. So the perimeter is equal to the arc length. We know arc length is r theta. And then we need to add those 2 sides. 25 plus 25 is 50. So we have the radius of 25 times theta in radians. We've already worked that out as 11 pi on 6. And I'm going to add 50. $193.99 meters. Okay, and that's the perimeter of the major sector DAC. Alright, last question with a few parts. Consider the diagram below. Find the lengths of the minor and major arcs formed by the 2 radii of a circle. So I might call this arc lowercase l, and I'll call this one capital L. This is green. Okay, so minor arc is r theta, radius is 5, and we need theta in radians. So I'm going to take my 150 degrees. I'm going to divide by 180, which is 5 pi on 6. Okay, so that's equal to 25 pi on 6. If I want to work out the length of the major arc, I'll use capital L for that. This angle here is 360 minus 150, which is 210. 210 degrees is equal to 210 divided by 180. So 7 pi on 6. So r theta, radius is 5, multiply it by 7 pi on 6. That gives me 35 pi on 6. Okay, and the units are meters for both of them. Okay, now it's time to find the areas of the minor and major sectors. So here's our sector, our minor sector, and all of this is the major sector. So area of the minor sector we know is r squared theta on 2. Radius is 5. Theta we already worked out as 5 pi on 6, because that's the size of the angle in radians. And then we need to divide that by 2. Alright. Let's do this to 2 decimal places. So we have 5 squared, actually let's do it like this. 5 squared times 5 pi on 6 all over 2. 32.72 square meters. And the area of the major sector, we know we're just going to keep using this formula so we get used to using it. 5 squared times, well, theta is 7 pi on 6 for the major sector. I'm going to divide that by 2. I'm just going to change that one to 7. So 45.81 square meters. Okay, so those are the areas of the minor and major sectors. We're now going to find the area of triangle POQ. So I am going to just highlight that in blue. I'm going to find the area of this triangle here. Now, in order to find out the area of this triangle, we need to use the area is equal to half AB sine C. Okay, so that's the formula that we use. Area is equal to half AB sine C, where angle C is the angle that's in between the 2 known sides, A and B. This angle here, 150 degrees, is in between the 2 known sides, 5 meters and 5 meters, because they are both radii, and radii are equal in a circle. So, area is equal to half times 5 times 5 times sine of 150. .25 square meters. So this is the area of triangle POQ. I might write this as area of triangle POQ. Okay. And very last question, find the areas of the major and minor segments. So, let me just get rid of all of this. What is in blue here, that is the minor segment. This is the minor segment. So if we want to work out that area, all we can do is use the area of the minor sector that we already worked out and subtract the area of the triangle, which we already worked out. So area of the minor segment is equal to the area of the minor sector minus the area of the triangle. The area of the minor sector is here. 32.72. And we're going to subtract the area of the triangle, which is the 6.25. $32.72 minus the 6.25. 26.47 square meters, and that's to 2 dp. If we want to work out the area of the major segment, okay, so the area of the major segment, let's highlight that in orange. All of this is the major segment, which means what we could do is just use the area of the major sector and add the area of the triangle. Okay, and because we've worked them both out, it's nice and easy. So it's equal to the area of the major sector plus the area of that triangle. The area of the major sector is 45.81. Area of the triangle is 6.25. Put that in the calculator. .06 square meters, and that's to 2 dB. Alright, and that's it for this video.